Hello, I'm Dr. St. John. Today I'm continuing with Chapter 3 of Cliff Ragsdale's book, and we're continuing with the Blue Ridge hot tub model. If you recall from Chapter 2, and finalized the mathematical model, which you can find on page 47 of the book. On page 21 of the book, that's where the original problem description is, where we drew the information in order to create the mathematical model. And today we're going to look at creating a computer model. So we're going to model this in Excel and we're going to solve it using Frontline Solver, which ships with all versions of Excel. So let me go to the next sheet here. Just a reminder, the Blue Ridge hot tubs produces two types of hot tubs, the Aqualux and the Hydrolux, Aquaspa and Hydrolux. Each one requires one pump. The Aquaspa requires 9 hours of labor to make. The Hydrolux requires 6 hours of labor. The Aquaspa has 12 feet of tubing for each one that's made. The Hydrolux, 16 feet of tubing. The unit profit is $350 per Aquaspa. The unit profit for each Hydrolux made is $300. And here are our constraints. And think of these in terms of constraints. We only have 200 pumps. We only have 1,566 hours of labor, and there's only 2,880 feet of tubing available. So the question, recall, the decision we're trying to make is how many Aquaspas and how many Hydroluxes can we make to maximize profit? Now we translated this is a summary here of the problem. We translated it, I'm going to move it out of the way. We translated it into this mathematical model over here on the right, and I'm going to leave that up because what you want to do is first take the problem and create the mathematical model, and then take the mathematical model and we're going to enter that and make our model in Excel, our computer model that we can solve using Solver. So the first thing along the top here, so up at the top we have max 350x1 plus 300x2. That's our objective function. 350 and 300, those are our objective coefficients. 350 is tied to x1, which is the first model, a hot tub, and that's a profit associated with that model of hot tub. So let's model that first. We're going to go over here. And that's the X1 is the Aquaspa. We can call it X1. That's fine. And X2. Probably nicer is to call it Aquaspa and Hydrolux. So what are these? These are just labels. In Excel, it's very important to have labels to identify what you're doing, what's going on. A lot of times you'll just see these Excel spreadsheets that have a bunch of numbers and you don't know what any of the numbers are. So we are identifying using labels what the associated numbers are. We're going to put our decision variables just below them. Let me make sure I have them in kind of the same spot. That looks good. So we have two decision variables, how many Aquaspas and how many Hydrolux. I like to take the decision variables, put the background in yellow so I remember that these are my decision variables. Just for me, it's a habit I do. Use borders to wherever it makes sense. Organizing this by column. X1, the Aquaspa, my first decision variable, it's column B. My second one, it's column C, the X2, Hydrolux. And if I have a third model, I'd put it in column D. This model, I want to set it up. I'm setting it up so that it can be expandable, easily expanded. I can just add columns, and if I have 60, 70 decision variables, no problem. I'll have 60, 70 columns in my model. I'll have 60 or 70 labels to identify each one of these decision variables, and each decision variable I'll make in yellow so that I know which it is. But this is a very simple model. We're keeping it simple, but you can see how it'd be easy to expand this. So I want to keep my decision variables together. You'll see more, but that's one habit you want to get in. Keep the decision variables together. So this is going to be number to make. How many do I make? X1. I don't know. X2. Solver will tell me how many. So there's nothing in those cells. Over here to the right, I'm going to put a label and call it profit. I can use this format painter, and I'm just going to, make it the same background color to let you know this is just a label. And below profit, I'm going to again use borders, and this time let's shade it. Let's make it kind of a purpley color. So this purpley color here, that's going to be my objective function. That's max 350x1 plus 300x2. I'm going to put my formula in there. Directly below the decision variable, I'll put my objective coefficients. 350 is associated with the aquaspa. So that's why I put 350 in column B. 300 is associated with the Hydrolux, so it's going to be in column C. So I'm organizing this by column B, column C. We can center it if you like. And if I have more, again, each column is a different decision variable. Each column has a label. Each column has the actual decision variable, which is the x1 or x2, the number I don't know that Solver's going to tell me. Those are in yellow. And then below them come the coefficients. In this case, it's profit, right? 350 or $300, that's the profit. Let me get rid of some of the decimals. I don't care about decimals right now. The $300 or $350 is the profit. If I was trying to minimize cost, then it would be terms in cost, not profit, but it'd be some number there. So whatever the coefficient is, usually profit or cost, but it might be number of votes, right? Maximize the number of votes I get if I'm trying to plan out somebody's political campaign here. Next come the constraints. So I'm putting the decision variables together. I'm organizing them by column. I'm going to put the constraints together below the decision variables.